Hi, in this video I will move to section 7.2 trig integrals and focus on the problem type that covers only sin x and cosine x. So the question you're gonna look something looks like sin x to the m's, cosine x to the n's, dx. Okay, and for this video I will show only this question type, m or n. Either one is an odd number or they both are odd. Positive odd, okay? Positive and odd. Say you're gonna see question like this: sin x cubed cosine x squared dx, sin x fourth cosine x fifth dx, sin x 3 to the cube cosine x to the cube dx. So in another word, as long as you see these odd numbers existing, that falls into this problem type. Okay, we don't really care who carries it, who carries odd power. So okay, let's see. This one is a summary for the question type we're gonna see in section point 2. Let's say the first part is sin x cosine x, integral of the sin x to the m's, cosine x to the n's. The second type is integral secant x to m's, tangent x to the n's. So we want to pay attention. Sin x always comes with cosine x, and secant always comes with tangent. You don't want to mess things up. They wouldn't do that. So we are here in this problem type for the first type. Okay, all the numbers, as I just mentioned, what the question gonna looks like, right? Okay, so let's see how we solve this. Oh, by the way, I want to mention to the m's, to the n's, these powers are high powers. High powers indicates greater than 1, okay? You will see sin x squared cosine x dx, right? This is a higher power which is greater than 1. As long as you see those bigger numbers, it falls into this section 7.2, okay? So here we are solving this type of question, odd number. As long as I see odd number, I'm gonna use this formula. This is my key formula for this question type. Sin squared plus cosine squared equals 1. Let's see how to apply it. See the question: integral sin x cubed cosine x squared dx. Surely I see it is high power, right? Greater than 1, 2, and 3. And I see an positive odd number 3 here. So the method here is I want to split this odd number into an even number plus 1, which is 2 plus 1 here, right? I want to separate this out. So I rewrite my question. I don't care what the other one carries, okay? I only carry this carries this odd number. So rewrite it into sin x squared multiply sin x, change into square plus 1, right? By cosine x squared dx. This part I only copy it. So I want to rewrite it into sin x squared cosine x squared sin x dx. This is same. I just change the order. I put the sin x back with my dx. For the, I split it into an even number plus 1. For this 1, sin x itself, I keep it with dx. For this even number 2, right, sin x squared, I use my key formula, which is this one. I always use this one for this question type, positive odd number question type, under sin x, cosine x, right? Under my first problem category, sin, cosine. So, okay, what is the second category? Secant, tangent, right? But we're gonna see it later. This we write into 1 minus cosine x squared, sin squared, cosine x squared, copy sin x dx. I don't want to change anything for this part because what I want is this. This is, I make up for substitution. U equals what? Cosine x. Because du is negative sin x dx. Negative sin x dx. Plug in. So for here, I see sin x dx is what? Negative du, right? Here is 1 minus u squared, negative du. Okay. Equals, I take this negative sign out, which is negative integral, and plug this in, multiply this in, which is u squared minus u to the fourth du. Solve this. Negative 1/3 u cubed plus, which is negative with negative 1, right? 1/5 u to the fifth. Don't forget plus c. Okay, so the last step is plug in my substitution, which is I did here. U equals cosine, so this equals, I write it to here, negative 1/3 cosine x cubed plus 1/5 cosine x fifth plus c. This is my final answer. Let's see the method. Once I find sine and cosine, they always come together, right? There is a positive number 3 here, so I split it into even number plus 1, which is 2 plus 1 here. I rewrite my question. I put the sin dx together, which is 1, right? So the left part, the even number, I rewrite with my key formula. Key formula is this. I always use this one. So 1 minus cosine square, and then do substitution. Okay. Let's see next one. Okay. Integral sin x to the negative 2, multiply cosine x to the fifth. I want to find, I know this is sine and cosine problem, and find here is a positive odd number 5. Yes, this is my question, this question type, right? So I want to split into even plus 1, which here is 4 plus 1. 4 plus 1 is what? 5, right? Rewrite my question. Again, what is left here? I don't really care. I copy it. Sin x negative 2. Cosine x to the fourth. Cosine x dx. Okay. Sin x negative 2. Copy. What is even number here? I separate into cosine to an even power, which is 4 here, right? So for this part, I rewrite, use my key formula 1 minus sin x squared This is what? Cosine square, right? Here is fourth square, which is fourth, right? And for this 1 power 1, this part, I keep it, cosine x dx. I always keep it with dx because I use it for, save it for later substitution. U equals what? Sine x. Du is simply cosine x dx. Here, which equals u to the negative 2, 1 minus u square du, right? And again, I want to multiply this out. U to the negative 2, 1 plus u to the fourth minus 2 u square, right? A plus b square equals what? A square plus b square plus 2ab, right? Du. And I need to multiply it in. Okay. So u to the negative 2 plus u square minus 2 du. Okay. Solve it. Negative u to the negative 1 plus 1/3 u cubed minus 2u plus c. And I want to see this part. Negative u to the negative 1 prime equals what? Here is a negative 1 multiply u to the negative 1, right? So I copy my constant here. Multiply the power, take it in front, u to the power minus 1, right? Minus 1, negative 2. So this goes to positive 1, right? So this equals u to the negative 2, which is here. So you always want to test if you can go back. If you can't, you probably make a mistake. So the last step is plug in substitution. U equals sine, so negative sine x negative 1 plus 1/3 sine x 3 minus 2 sine x plus c. So this is my final answer. Okay. So what I really care and I want to find is positive odd number, right? As long as it's all about sine and cosine. When I find it, I separate into even plus 1. The rest part I just copy. Later, I could solve it by using substitution. So that is this one. Let's see this one. Integral sine x cubed cosine x to the 5th dx. Question is all about sine x and cosine x, and I want to find positive odd number, which is they both carry a positive and odd power 3 and 5, right? In this case, I want to randomly pick one to split into even plus 1. Okay, the method is still same, but I don't want to split both. Okay, it won't be helpful, which means I don't want to do this. Sine x squared, sine x, cosine x fourth, cosine x dx. No, I don't want to do this. I only want to pick one odd power and separate it. Okay, so now I pick cosine here. You can pick sine as well. So let's see. I rewrite my question into the part you don't separate, you just copy it, sine x cubed by cosine x fourth, cosine x dx. Okay. So for the even part, I rewrite use my key formula, right? Which is sine x cubed 1 minus sine x squared. This is cosine x square, cosine fourth, cosine x dx. u equals what? Sin x. du is cosine x dx. So this equals, so that's why I want to pick this cosine, because if I do substitution, u is sine, I directly goes to cosine x dx. But if I want to pick this sine cube, separate it out, you could try by yourself. Later you're gonna set u equals cosine x to do your substitution, and then du is negative sine x dx. You still could solve it, but you want to be careful with this negative sign. I want to make things easier, so I choose this way. Okay, they both works, but this is, I think, is easier. So plug in u cube 1 minus u square du, right? I don't need to worry about any negative sign here. So I want to multiply it out. U cube 1 plus u to the fourth minus 2u squared du equals u cube plus u seventh minus 2u to the fifth du, right? Yes. And this equals 1 over 4 u to the fourth plus 1 over 8 u to the eighth minus 2 by 1 over 6 u to the sixth plus c. This 2 I just copy it here. The last step is plug in your substitution. U is here. 1/4 sin x to the fourth plus 1 over 8 sin x to the eighth minus this I can compute 1 over 3, right? Sin x 6 plus c. This is my answer. This is my answer. So, okay, as long as I find sine and cosine, they both carry the positive odd power, I randomly pick one to split it out, okay? Let's see this one. Again, sine, cosine. I find a positive odd number, which is 3 here. I want to separate this 3 into 2 plus 1, which rewrite sine x to the 1/2 cosine x squared cosine x dx. And for the even part, rewrite by my key formula. Sin x 1/2 1 minus sin x squared cosine x dx. Substitution, u equals sin x. Du is cosine x dx, which is here. This goes to u to the 1/2 1 minus u squared du. So this equals u to the 1/2 minus u to the 5 over 2 du, right? You multiply this in, this is 2 plus 1/2, right? 5 over 2, 5/2. Solve it. This is gonna be u to the 3 over 2 by 2 over 3 minus u to the 7 over 2 by 2 over 7 plus c. For this 2 part, you want to do derivative of it, see if you can go back, right? And here is this part. You want to test by yourself, and I just want to plug in the substitution back, which is sin x 3 over 2 to the 3 over 2, this is the power, okay, by 2 over 3 minus sin x to the 7 over 2 by 2 over 7, multiply this plus c. This is my answer. This is my answer here. Okay, so I want to give a brief summary about this part. So how to recognize this question is, I know this is sin x, cosine x carries higher power, which is greater than 1, right? Power greater than 1, dx. So as long as I see a positive odd number, I don't worry who carries it. I know I'm gonna separate the odd number into an even plus 1, right? For example, here I separate into 2 plus 1. So that is, if one carries an odd power, I can do this. But if they both carry an odd power, positive odd, say sin x cubed, cosine x cubed, I only randomly pick one to split into even plus 1, right? And the rest part I just copy, and the rest part I just copy. Okay, so later for this even part, I rewrite it into my key formula, right? My key formula is always sin x squared plus cosine x squared equals 1. So I want to rewrite it and do substitution. Do substitution, plug in, and you can solve it, right? Okay, so I wish it's clear, and see you in my next video. Bye bye.